Hello friends, I'm Samir and I welcome you all to your own YouTube channel Aryabhatta. Friends, today we are going to discuss about solving a system of linear equations using determinants, and that use of determinants to solve a system of linear equation, it is called Cramer's rule, named by the mathematician Cramer's. Okay, so we are today going to learn how to solve a system of linear equations by Cramer's rules using determinants. Now first of all, let's come to know what is the actual meaning of system of linear equations. So a system of equation means more than one equations combined together, and if you are willing to find a common solution of the variables used in the equations, more than one equations combined together, then that is called a system of equations. Now, when it is called linear, it is called linear. The equation is called linear equations if the power of the variables used in the system or used in the equations are all 1. That means whichever the variables are used wherever in the equations, their power should be only 1, not less than 1, not more than 1. So this type of system containing more than one equations, linear equations, is called system of linear equations. So in general, friends, let's use a system of 3 linear equations to solve or to discuss our topic. So for that I have taken a system of 3 linear equations containing 3 variables x, y and z, and the equations are a1x plus b1y plus c1z is equals to d1, a2x plus b2y plus c2z is equals to d2, a3x plus b3y plus c3z is equals to d3. So friends, here you can see the power of the variables x, y, z are always 1 here. Here a, b and c with their subscripts are the constant real coefficients of the variables x, y, z respectively, and the right side constants d1, d2, d3, they are also real numbers, but they are without any variable coefficients. That means no variable are attached to them, they are pure constants, you can see. Okay friends, now the use of how to solve this one with the use of Cramer's rule. Now the solutions of this system by Cramer's rule, its formula is very simple. The solution, the value of x is equals to del x by del y, the value of y is del y by y, and the z value is del z by z. So don't misunderstand that del x means x is multiplied with del. Del always represents the determinant, and if I am writing del x, it doesn't means del is multiplied with x, it means a determinant associated with something associated with the variable x. So here I am writing x as a subscript, not as a factor of multiplications. So it's not that del x by x means del you will cancel and you will get x. It is del obtained out of or with respect to x. So similarly del y means del obtained out of or with respect to y, and del z is also a determinant obtained with respect to z. Now in which respect it is obtained, that we are going to discuss below. So the del which is divided in the all the 3 values here in the denominator, it is nothing but the determinant of the body matrix obtained from the system. That means here the determinant contains elements which are nothing but the coefficients of the variables x, y, z in their proper order. The first row represents the coefficients of the first equation, second row from second equation, third row from third equations. Okay, and here the variables are also arranged in their proper sequence. That means in all the equations x is written first, then y, and then z. Okay, so this is the determinant del. Now del x, as I told you that x is not multiplied with del, It is a determinant associated or obtained or with respect to the variable x. Now here the first column in del, you can see the first column a elements a1, a2, a3, they are nothing but the coefficients of variable x. So if I am respecting this x column or first column elements with the right side constant coefficients d1, d2, d3, keeping the other two columns as same as before, then I am getting a new determinant that I can write del x. So why it is called del x? Because it is the determinant, del is the determinant, and x means I am removing, I am exchanging x, I am removing or replacing x with the constant column d1, d2, d3. Similarly in del y, the second part, the second column, which is the column of y, will be replaced with the constants, keeping the first and third as same as before, as in del. And the last del z, here the z column is replaced by the constants d1, d2, d3, where first two columns are same as before as in del. Okay friends, so in that way we are getting four determinants. What we will do now, we will first of all write the determinants and we will find the value of them, then we will put them in this formula given by Cramer's, and we can directly get the solutions of the variables x, y, z without any hesitations. But as to get the solutions, we have to divide a number with another number. So the nature of the solutions, or whether the solution will exist or not, or whether we can get a solution or not, and if we will get a solution, then it will be of which type of solution. All these things will depend on the values of this del x, del y, del z, and also the value of del. So we can write them, we can divide them in four different categories in a table, and we can discuss the different pages or categories where the nature of the system and the nature of the solution we can see in a proper or clear picture there. So here friends, I have written for you all these categories. You can see in the first category, if the del is not 0, but not all the del x, del y, del z are 0 at a time, that means some of them may be 0, but not all of them are 0 at a time, then we will get a consistent system, then the system will be consistent. System is consistent means we will get a solutions. Here the solution exists. That means we will definitely get the values of x, y, and z here. And what is the nature of that solution? The nature is unique solution. That means you will get only one set of values of x, y, and z here. You will not get any repeated values of the same variables. Okay friends. Now the second category says that if the del is not equals to 0, but all the del x, del y, del z are all 0 together, in that case also the system is consistent. That means you will get a solution here, and the nature of the solution is trivial solutions. Friends, trivial solution means if the values of all the variables are 0 at a time, then it is called trivial solutions. So here in this case, the values of the variables, if the variables are x, y, and z, then they all will be 0. Their value will be 0 at a time. The third stage says that if the del is 0, but not all del x, del y, and del z are 0 at a time, in this case, this is the only case where the system will be inconsistent. Inconsistent means you will not get any solution here. Here the nature is you will get no solution. No such values of x, y, z you will get here. So remember friends, this is the one and only one case where the system is consistent and you will get no solutions. In all the other three cases you will get some sorts of solutions. The fourth stage says that, fourth category says that if the del is 0 and simultaneously del x, del y, del z all are also 0, then also you will get a system which is consistent. That means you will get a solution here, but the nature of solution is infinitely many solutions. That means you will get infinitely many set of the values of x, y, z which will satisfy this system together. Okay friends. So this is the category. Now let's what to do? Let's take a good example of system of linear equations and let's solve it by Cramer's rules. So, I have taken one example here. You can see I have taken a 3 variable system, linear equation system to solve. Now, before moving for the solution part using Cramer's rule, first of all let me check whether they are in the proper sequence of the variables x, y and z or not. That means x is in the first place, yes, y in the second place and z in the third place, and right side I have only constants. So, this system is in the proper form. If it will not be in the form, you can take one step and you can replace their positions and you can bring them to the proper order. But as it is in the proper order already, I do not need to do anything here. So, what I will do now? I will find out my 4 determinants obtained out of these systems. First determinant del will be the body determinant, that is the coefficients of the variables x, y, z from the equations taken row wise. Okay. So, it is like this 1, 2, 3, 2, 1, 1 and 1, 1, 2, nothing is multiplied means it is 1. Okay. So, you can find the value of the determinant, and here I am getting it is minus 2, which is not equals to 0. If del is not equals to 0, then you know in both the cases the system is consistent. That means I can write the system is consistent, that means a solution exists here. I can move for the next stage. Next stage is to get del x, del y, del z. I told you del x where this first column of x 1, 2, 1 is replaced by the constant column 8, 8, 6, keeping other two as they are, and the value is minus 6. Similarly, del y is the determinant where the y column means the second column is replaced by the constants 8, 8, 6, keeping the other two as same, it is obtained as minus 2, and del z where the third column is replaced by the constant column 8, 8, 6, keeping the first and second as same before, and that value also I am getting as minus 2. Okay, friends. So, here del x, del y, del z all 3 are not 0 at a time. If del x, del and del z are not 0 at a time, this is the first category. Okay. And what type of solution we are going to get? I can now predict that what type of solution I am going to get. Before calculating, I can predict the nature of the solution, and I am going to get a unique solution. That means, here I am going to get only one possible values of x, y and z. The values will be not repeated at all. Okay, friends. So, the unique system is unique solutions exist here. Now, apply the Cramer's rules. So, x value will be del x by x, del x value is minus 6 by del value is minus 2, you are getting 3, y is del y by del, that is minus 2 by 2, that is 1, and z is del z by z, del z value is obtained as minus 2 divided by del value minus 2, it is obtained 1. So, in that way we are getting the values of the variables x, y, z as 3, 1 and 1. So, friends, it is a very simple method in which way we can find the solution of the system, and also it is helpful to check whether the system is consistent or not, whether the solution will exist or not, and also it helps us to check the nature of the solutions without calculating them also. So, friends, I think you are little bit clear about the application of Cramer's rules in solving a system of linear equations. So, now you can go for more adventure and you can apply this method in solving different linear system of equations yourself. So, friends, thank you very much for watching this video.